Hey there, MVPDays fans. How are you doing this morning? I'm doing just great, and I'm here to talk to you today about Storage Spaces Direct. It's a topic that's near and dear to my heart, and I really hope you enjoy what I've got in store for you today. What we're going to do in our quick 20 to 25 minute session here is we're going to do a live build of Storage Spaces Direct up in my Azure tenant. I'm going to show you exactly what I do to build my lab, and then we're going to take a look at some of the brand new features that we have to manage Storage Spaces Direct with Windows Admin Center. I am Dave Kawula. You can get me on Twitter at Dave Kawula. You can check out my blog at www.checkyourlogs.net. You can contact me via email, and you can also check out my GitHub repository. I really hope you enjoy the session, and the best part about this for you is that's actually the last slide that we're going to have. Let's jump right into the lab environment and let's get going. Okay. So the very first thing for you, I love to give away free stuff. So if you don't have an Azure tenant or an Azure account set up today, you're walking away with $250 in your pocket. That's right. If you just go to azure.microsoft.com/free, you get $250 in Azure credits available to you. You can sign that up on your own personal account, and you can try things out today. So that's a great way to get started on a lot of these cloud-like services, especially with Microsoft and Azure, which is some of the things that I'm going to show you here this morning. The first thing we'll do is let's take a look at my Azure tenant. Let's see where we're going to actually run the lab. Come down to virtual machines. I've built a rather beefy virtual machine for this example. I'm actually using a D64S V3. This is a 64 vCPU and 256 gig of RAM virtual machine. It runs approximately for $5,000 a month. And you're thinking to yourself, you're crazy, Dave, to run your lab configuration like this. Well, in all reality, in the cloud, we only pay by the second and by the minute. We don't pay by the week and by the month. So when I'm not using this little guy is my friend, auto shutdown right here. So I'll use this auto shutdown functionality, and I'll make sure that I turn off this virtual machine when I'm not using him. So at 11 p.m. tonight, this VM is scheduled to turn itself off. So that's little trick number one to save yourself a lot of money. Also, what I'll do is I'll resize that virtual machine back down once I'm done my lab work to get a little bit more affordable scenario. Okay, let's go ahead and jump right into our virtual machine here. And there we go. So what I've built for the lab here today is I just have a couple of VMs that I built with my big demo script, which you've heard me talk about on earlier MVPDays webinars. And so basically I've got a couple of domain controllers, I've got the management server, and I've got a few VMs that I'm running here. Now the cool part about running this big beefy server, and I don't even really call it a virtual machine anymore, it's almost like a host in the cloud, a Hyper-V host, is I can actually run these VMs with like 32 gigs of RAM, and I think I put 64 vCPUs in each of these things. So I got 64 vCPUs in each of them. I've got a C drive where I've got the OS, and then I've got 4 data drives which we're going to use for Storage Spaces Direct. So our build will kind of look a little bit like this. Let me just pull up my master MS Paint skills here. So what we're going to have is we're going to have 4 nodes. So I'll have node 1, node 2, node 3, and node 4. And these guys have some associated hard drives in them, so we'll just say that he's got 1. Let me just copy this. Oops, I didn't want to do that. Let's cancel that. Just draw a few little hard drives here. So he's got 1, 2, 3, and 4. So each of these boxes basically have 4 hard drives inside of them. Okay, so we'll just assume that they're all the same. So we've got 4 hard drives in each, a total of 12 drives that we're going to take and chain together for what's called our storage pool. So when these start off, they're just JBOD disks, just a bunch of disks is what JBOD stands for. So I've got a total in here of 12 drives. I set up the VHDX files in here. A little bit dyslexic here this morning. So the VHDX files with a 10 terabyte dynamically expanding disk, just so that when we look in the UI, we can actually see some things going on. So I'll have approximately 120 terabytes of raw space in here. So that's going to be a cool design that we're going to have. So like roughly, sorry, not 120 terabytes. I'll have 160 terabytes of space, 40 terabytes in each raw, and so that's what I wanted to take and I wanted to show you for our initial setup. And this is going to form initially a storage pool, and then we'll build our disks. But enough with that. Let's actually get into our nodes and take a look at the builds. So these machines are basically just joined to the domain, and they have a very basic network config where they've just got an IP address, and that's it. So just some regular VMs that you have stood up and you've made available. Now there's one little trick to getting this set up. Inside of your Hyper-V environments, if I want to run what's called nested virtualization, that's where I can run a Hyper-V host, and then I can build a VM, and then I might want to build some more VMs underneath it. It's called nested virtualization. I have to run one little command on my guests here in order to make this work, and these will have to be off in order to turn this on. So this would be the command I'll run. This is going to fail. I'm not going to finish running it, but I'll just show you what it is. And this is the command to expose the virtualization extensions in order to get nested virtualization working. So what I'll do is I'll do get VM, and then I'll just run s2d star. This will get all of my storage spaces direct nodes that I want to enable this on. And then I have to make a change to the VM processor. So I'll say set VM processor -expose virtualization extensions true, and this will fail. I'll press enter. It'll say sorry, the machines actually need to be off in order for that to be on. It looks like it actually succeeded here, but the VMs actually need to be off in order to make that setting, and then we can actually take and install the Hyper-V role inside. The other thing that I've done to these machines, just to save time, just because I've only got a limited amount of time for the demonstration today, is I've already installed the Hyper-V role and Failover Clustering role on here. So it saves 2 reboots, and it just speeds things up a little bit. Okay, so let's go into my management server. I've got my master PowerShell script here that we use. Where you can find this script is up on my GitHub repository. So it's just github.com/dkawula, DKAWULA. You'll go to the operations repository, and I've got under S2D a demo script in there, and that's where we've got the context for what we're building. So it's really simple for the initial setup. All that I did is I took and I installed Failover Clustering, Hyper-V, file services, and data center bridging. In your lab environment, data center bridging is optional because I'm not going to be using some of the advanced networking configurations like RDMA in this particular lab. As I take and I scroll down through here, we've already done a few of these, so this would be more for a physical configuration. We can take and we can set some of the data center bridging configurations in here. So let me go ahead and do that. So I'm going to go ahead and run this. This way at least you can see what it kind of looks like. So if you had an RDMA capable switch and you wanted to run RDMA over converged Ethernet or RoCE, these are some of the settings that we would turn on in the lab. Not everything quite works, but at least you can see what everything is supposed to look like. We're going to go ahead now and we're going to build a switch on these virtual machines. So let's just log into one of these nodes here. Let's take a look at the networking configuration. All right. And this is what we've got for networking configuration. I've got an adapter called Ethernet, and that's it. That's all that I've got installed in the lab. And I want to show you how this builds out as we take and build out the environment. So let's actually run this a little bit split screen here. We'll run this over here. And we'll bring up this management node right here. It's kind of cool. The reason I do this is because then you can actually see what's going on. Like I said, a copy of my script's fully available for you on my GitHub repository. So don't worry there. You'll get a copy of everything that I'm using here today. So the first thing I want to do is actually just build this this virtual switch VSW01, and I want to use switch embedded teaming in here. And I'm going to create my first management adapter on each of the nodes. So what will happen in here is this adapter will show us disabled for a second while that's getting created, that virtual switch is getting created, and then you'll see my first virtual adapter coming on board. We're going to use this virtual adapter to communicate with the virtual machine in order to take and complete these configs. The other cool part about the scripts that I'm showing you here today is these will all work on production machines. This particular script is one that I actually use in production quite often. So as soon as this is done, then we'll go ahead and we'll build out the rest of the virtual adapters, and I'll just explain what I'm doing with these particular virtual adapters. I always create 2 SMB adapters because Storage Spaces Direct does run over the SMB protocol. And I'll have one, especially if I've got multiple switches, so I want one of these going through switch 1, one of these going through switch 2. I'll have my live migration traffic isolated, and typically I'll put these on separate VLANs as well. Then I'll have my heartbeat traffic and my management traffic. Now, if you ever find that this script is stalling out, it's because the DNS names need to get readjusted. So if you just run an ipconfig flush DNS, sometimes that'll push the script along as well. We can see that all the connections are currently being restored though, so we're in pretty good shape there. All right, so let's go build these virtual adapters. So these virtual adapters will get created now, and we will see them actually popping in. So if we take a look over here, they're getting created. So I've got my different SMB adapters that are getting popped in. And most of this is all prerequisite work that's required before you're going to take and configure and start using your software-defined storage. And this is really hyper-converged infrastructure from Microsoft that you're building here today, or that we're building here today. Then optionally, we can set some VLANs if we were in production, so I'm not going to worry about that here in the lab. And keep coming down. And so really, there's not a ton of code that we actually have to run in here. You might want to restart the network adapters if you did set the VLAN. There's a little bug where the VLANs sometimes don't take. Now I want to configure the IP addresses on all of those newly created virtual adapters. So this will just go plug in a bunch of IPs on these things for me. You always want to make sure that things are pingable once you get things stood up. So if I go ping 10.10.16.16.2, 16.3, and 16.4. I can't reiterate how important this simple step is, especially when you're dealing with VLANs and you're not in charge of the network infrastructure. I've seen so many Storage Spaces Direct implementations slow down or fall down because we anticipate that switch configurations are going to match what we're going to be setting up, and they don't. So after you IP these things and set the VLANs, always make sure that you've got connectivity across them. And so I even build that into the script here properly. The next one is if your nodes have a lot of RAM on them. So let me just pull up my advanced networking or my advanced system properties here. So computer. Sorry, my mouse is sticking a little bit here today. What we're going to do here is, let me just show you this setting. It's going to be under Startup and Recovery. And you see how there's an option here for an active memory dump? Typically, you're probably most familiar with an automatic complete kernel or small. Active memory dumps was something that was added in Windows Server 2016, and it will consume approximately 7 to 10% of the available RAM. So in this case, I've got 32 gigs of RAM on these systems. A memory dump on a blue screen would consume about 3.2 gigs. Now, if you think about these monster servers that we're building out in the field today, they could have 512 gigs of RAM to, even a terabyte of RAM. Well, who has a terabyte of space on their C drive that they can store the memory dumps? Nobody. So this is where the active memory dumps come in. And this little piece of code right here actually sets that. So that sets those item properties, and that's the configuration that's going to be getting made there. Now the next step that we're going to go through is actually the storage spaces direct. So if your networking's set up and the disks are ready to go, we're actually ready to proceed. Now there's a couple little tricks for working with storage spaces direct, and these are a couple really handy commands that you're going to learn as you're working through this process. This one here is going to actually take and just check the storage subsystem on each of the nodes. And so I'm just checking through node 1, 2, 3, and 4, and we want to make sure that everything says healthy here before we proceed. The next thing is if you're building inside of a lab environment, the media type may show up as unspecified. So what you want to do is you want to actually change that so that the media type will read SSD. You can change it to anything you want. So like, for example, if I check my media type that I've got right now, it's going to show all SSD drives across each of these nodes. The other thing I want to point out is that one of these drives in here says can pool false, and the reason for that is actually your boot drive. The other disks in a hyper-converged configuration like this should all say can pool true. If any of your disks don't show can pool true, do not proceed. Go clean up your disks. You probably have some stale metadata. They're not brand new drives, or something else is going on the disks. And I wanted to just show you how we could change the media type around. So if I wanted to change the media type in here to a standard HDD instead of an SSD drive, we can actually change the media type around in the lab. And we can change the kind of emulation and the way that the screenshots would show up inside of here. So you now see how I have all HDD drives in there. So we can just change this back to SSD. So you might get a little stuck in your lab build if you don't run this little setting. I don't typically have to set that in production. That's only a lab thing. All right. Good stuff. Okay, the next thing we're going to do is we're going to run a cluster validation. And with our cluster validation, we are going to take and just make sure that the cluster is actually going to be ready to go for us here. And so the rule of thumb here is that you don't build a Hyper-V cluster or storage spaces direct hyper-converged cluster unless you're passing these cluster validation tests, because this is what Microsoft uses for their support policy. If your cluster doesn't pass, then they'll reserve the right to not support you until this actually does pass. So we can say that the cluster is approved but had some failures in it. So if you want to view that report, the report is actually stored in C drive Windows cluster reports. We're not going to worry about that for this demo today because we really want to get this live built set up. So the first thing we'll do here is, now that we've got that cluster ready to go, we're going to take and we're going to build the cluster with a single line here. So here's the deal. If you have everything ready to go, your VM is on the domain, it's fully patched, it's racked and stacked, you've got your networking configuration done, setting up storage spaces direct in a live build is realistically, if everything is working properly, 2 lines of PowerShell. This is one of them. So the new cluster command will actually form the cluster between these nodes that I've got, and we'll set an IP on the cluster of 172.16.100.244. And then the second one is going to be a command called enable cluster S2D, which you'll see a little further down in the script. But those are really realistically the only 2 lines of PowerShell that we need to run to configure storage spaces direct. So we'll build the cluster. I'm going to build this as S2D cluster 1 because I had another cluster in there that I didn't destroy properly. And that is why that's a little grumpy on me. I forcibly removed the nodes from the cluster. So that's why I didn't tear it out properly, and I didn't get rid of the Active Directory CNO, which is the computer name object that lives in Active Directory. We could have cleaned it up by just going through and deleting it, but in a short little demo like this where we're trying to keep things tight and concise, we want to take and make sure that that everything is going to just go quickly and work well for us here. After we get this built out as well, I want to show you what the interface inside of Windows Admin Center looks like to manage this and to create our volumes and do things like enabling deduplication on our nodes. Okay, so that looks good. If we want, we can actually open up Failover Cluster Manager here. And inside of Failover Cluster Manager, we will just go ahead and connect. See all the pop-ups. And if you're wondering what OS I'm running on Windows Server 2019. This is still on one of the insiders builds because Server 2019 hasn't quite dropped to the market yet. So we'll just pull up this cluster, S2D cluster 1. And we should see 4 nodes in here. Perfect. And if we come to storage, our storage section is still going to be blank because we haven't enabled our hyper-converged infrastructure in here yet. So once we run the command enable cluster S2D, everything will nicely show up inside of here. The other thing is that if we run this command get physical disk again, I want to show you how this now changes, because remember how there's only 4 drives? Each of these nodes will actually see all of the disks because they're part of the cluster. So do you see how each of the nodes is seeing all of the drives inside of here? So that is a normal view that we would be looking at. Okay, so everything looks good. We're ready to go. So I'm just going to go ahead and scroll down here. And this is the second command that we need to run right here. So we're just going to enable cluster S2D. Invalid namespace. Oh, I have to run this. Sorry, I have to run this against one of the nodes here. Invoke dash. I'm running off the management server, which isn't part of the cluster. So invoke command dash computer name. Oops. Dash computer name S2D1 dash script block. And I'll just wrap that. There we go. That should work for us. So we'll basically just invoke that command to run it on node 1. So now it should see all 12 drives in here. And you can see that it's waiting for the drives to be claimed. So it says there's, sorry, not 12 drives, there's 16 drives total here. And if I take and go in here, and I open up disk management, you'll see a very interesting view and some interesting things happening. So there were 4 drives that would have showed up in here. They would have just been all black and unallocated. Because the storage pool and storage spaces directives claim them, you can't actually view them in the UI anymore. So that's kind of neat to learn and neat to see. This just takes a moment to actually complete. Always takes a little while at 27%. As this is going through, if we come over to this node over here, and we just open up PowerShell, and we just run a get dash physical disk, you'll start to see the view and the landscape change on the fly here. So you notice how right now there's only a couple drives that are showing up inside of here. Oh, sorry, I don't know if I went onto the right node here. I think it's still working through them, that's why there's only a couple drives left. So those drives will disappear here in a second as it takes and it proceeds through these. Just going to pause the video here and we'll come back as this completes. Oh, so the joys of a live demo. So this is taking a little longer than I wanted to, and I have to finish our recording tonight so I can get the rest of the sessions compiled for tomorrow. So what I'm going to do is I'm actually going to jump over to another live environment that's got this all finished up. So we've enabled Cluster Storage Spaces Direct. I want to show you what the finished product is going to look like from a management perspective inside of Windows Admin Center. Okay, so I've logged into Windows Admin Center and I'm just pulling up my hyper-converged view in here. And this is pretty neat because I can actually do pretty much all my management tasks that are required from the Windows Admin Center. And I can see active latency, throughput, I/O, memory utilization, storage utilization, CPU, if my drives are healthy, if my servers are healthy. I can actually go through here and even create virtual machines, see an inventory of everything that's running in here as well. So if I click on my inventory, I actually use this to set up Azure Site Recovery for a couple of my VMs. So let's let that go ahead and load. So I see some memory pressure. I didn't set it up on these ones here. I had it on another set of servers. So it's cool. We got some good visualizations I can take and I can start and stop resources. And then more importantly, I can come down to my volumes and we can actually see what's going on inside of our individual volumes. So I can see that I've got a two-way mirror set up inside of here. Go check out one of these particular volumes. I can see that I've got deduplication turned on using the ReFS file system. And so this is actually got a 315 gig savings or 62% compression. So pretty neat. You can see active drive information and stuff going on. And that's about all the time that I'm going to have for you today. I do have a couple extra free gifts for you here. If you head over to www.leanpub.com and you come into the store, just search my last name, and you're going to find our entire library of books. And on this particular topic, if you're interested in more information on Storage Spaces Direct, we've got a book in here, Master Storage Spaces Direct. And you can get any of the books in our library absolutely free of charge by simply just sliding all the way over to the left. It's an ebook. Our belief is that we want a forever free model for all of our content for you. So that's that. Second one is all of the content for the recent Microsoft Ignite show is actually available on demand. For the first time ever this year, Microsoft recorded all of the sessions, including all the theater sessions in the expo hall. And these are all available to you. Go and sign up for your free account at the Microsoft Tech Community. You can search any of the sessions on demand. I've got my sessions up there. They were recorded, and something pretty cool. My session here on going from zero to hero with Azure Site Recovery, surviving a ransomware attack. I did that session with Emil Cabot, and we actually tied for first place out of 1,800 speakers at the conference with that session. So that was pretty neat. Well, I hope you enjoyed this. I hope you enjoyed this session. I hope you enjoy the rest of the sessions today, and have yourself a wonderful month of October. We will see you again in November for our next MVPDays vConf, and then we've got a very exciting one coming up in December, which is a dedicated Microsoft Flow virtual conference. So have yourself a great day, and talk to you later.